Right, so hex is the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but we still need another 6 because there's 16. So we just go on to the alphabet. And it depends. Right, when you write hexadecimal, it depends on what your writing's like. I prefer, when I'm coding and I'm doing machine coding, you use hexadecimal all the time. I tend to write my hex values in lowercase because on a keyboard they look more distinct. If you're handwriting, be very careful that your handwriting distinguishes between the letters. If you've got any letters that you write that seem very similar, if you do lazy B's like that, be careful because that could be misconstrued as an A. Alright, so be really careful with your hex when you do it. Right, to convert between binary and hexadecimal, all you've got to do is group your bits into nibbles, 4 bits. So you can see by writing numbers like this, we automatically make it easy to do the hexadecimal. And what we do is we just say, well, treat that as a 4-bit number. So you just say to yourself, you can do it in your head because it's not complicated. You say, right, well, 4-bit number has got those columns. What is that value? So in that case, it's 11. 8 plus 2 plus 1. But in hexadecimal, 11 is B. So if we were to write that pattern of bits in hex, we would write B. We then look at this value, and we say, right, okay, well, it's just 4 bits again. So that's 1, 2, 4, 8. And if you want to put the column ends on, that's not wrong. So that's 2, isn't it? So that represents 2. So this number, which was originally 43, so 43 is equivalent to 0, 0, 1, 0, 1, 0, 1, 1, but it's also equivalent to 2b. So that's denary, that's binary, and that's hex, which is what you get on your calculators. Your calculators can do all these conversions, can't they? Which is why we're not allowed calculators for 1-mark questions. It's a bit bonkers, but there you go. Okay, so the process is that hexadecimal and binary were designed to work together. That's why we use hexadecimal. To go the other way is exactly the same process, and it's probably simpler. So if I have a hexadecimal value, can anyone tell me how many bits that would be in binary in total? 4 hex digits, how many bits is that going to be? How many bits for each hex digit? Did I just say? 4. So if we've got 4 hex digits, yeah, 16. So this is going to be a 16-bit value. I put B now. 16-bit. I got ahead of myself. Because each hex digit is 4 bits. So all I do is I say, right, well, what is 7 as a 4-bit value? So what is 7 in binary? Just as a 4-bit number. It's just that, isn't it? That's 7. A is 10. So what's 10 as a 4-bit number? 8 and 2, yeah, correct. 8 and 2. Yeah. So 8, 0, 2, 0. What's F? F is the easiest number to write down in hex. All the ones. 15. And then E is 14. So going from hex to binary is incredibly trivial. And going from binary to hex is incredibly trivial because the numbers you're dealing with are small. Even I can add up 8s, 4s, 2s and 1s without messing it up, generally. Okay? If you're asked in an exam question to take a number like 17 and write it in hexadecimal, the best thing to do is to write it in binary first. So if I was to write this in binary, I'd do my column headings. Normally I go the other way. Right, so 17, so it's going to be no. I can have one of them, obviously. And then just the one. So I've written the binary, and then I say, right, well, I've got to convert it to hex. So I'm just going to do that 4 and that 4. So it's going to be 1, 1. Okay, so there are other ways of doing decimal to hex. I will leave you to look those up if you want. I don't want to make it more complicated. Okay, the final thing that we're going to do, and then I'm going to leave you to do some revision for the rest of the sesh, is shifting. And then I'll give you a couple of questions to do. Binary shifts. So let's just look at an 8-bit number. So I'll do the columns here. 1, 2, 4. Right, if I have got this number, which we can see is 16, I'm going to keep it really simple for demonstration. If I move those bits to the right, so if I move all the bits one position to the right, what number will I get? 8. Yeah? So I would write Right, what is the mathematical operation? What was the effect of shifting to the right? Yeah, divide by 2. So when we go right, we divide by 2. What if I was to shift it to the left? Yeah, times by 2. Now you can sort of see this because that's what the column endings do, don't they? Every time you go right, the column ends half. Every time you go left, the column ends double. So this is times by 2. So one thing they'll ask in a GCSE question is, they might ask you to show a shift so many places, and then they might say, what's the effect? So when they say, what's the effect, they mean, what have you done? Have you divided it by 2? So let me give you this one to have a go at. So this pattern of bits, I want you to shift it right 2 places. Right, so have a go at shifting that right 2 places. You feel like you're going to be sick? Do you want to go toilet? Don't do it by converting it to decimal. Just do it, keep it in binary. They'll be interested that you can move it in binary. Again, this isn't something that's hard, but it's about making sure you don't screw up writing the answer down. And I'll show you a technique for doing this that you can choose to ignore if you want, but it's the technique I'm going to show you. Right, everyone had a go at that? Right, if we shift it right, what's the effect on these 2 bits? They disappear. That's critical. They just get shifted off into non-existence. So when we're shifting right, what we can do is we can do this. We can say, right, well, those 2 bits are going to go, so these are the ones that I'm interested in. Those ones. So I've skipped the first 2. So I'm actually going to write this number down. 001100. What happens with the gap that I've got? What do I put in the gap? What did I do on the previous one? When I shifted it? What did I put there? You fill gaps with zeros. So all I've done is, I haven't actually shifted it, I've just identified the bits that will get lost. And I've said, well, ignore those and write the number down, and then fill the gaps in, like that. Now we can check this. What number is that originally? Can anyone just read it? Not 43, 48. So this one's 48. What's this number? 12. What was the effect of shifting right 2 places? Divide by 2 twice. So divide by 4. So that was divide by 4. And actually this is really useful in a lot of algorithms. One algorithm that we'll look at, called binary search, does divide by 2. And we can do it super quick. That is, shifting is one of the quickest operations on the CPU. Okay, so division is a horrible process, and you know because you've done long division. But on a computer, if we've got nice numbers to divide by, super quick. Right, let's have a go at one more. So let's take this number then. Right, I want you to shift this one place to the left. Left. So this is going to be multiplied by 2. Right, so do that. Use the little technique I've just said. So identify the ones that are going to get knocked off, write the rest of it down and then fill in the gap. Yeah. Yeah. Left is multiplied, right is divided. Just all you got to do, look at your columns. As you go that way, you get bigger. As you go that way, you get smaller. Shift left one place, which is like effectively multiplied by 2. What do you get as an answer? All right. You should have an interesting answer. What number is that currently, anyway? Is it 175? It's going to be an odd number because we've got a 1 there, haven't we? In the 1 column. Yeah, you think? Yeah, it is 175. Right, okay, let's look at this then, because it poses a problem. So we should actually get 350 as the answer, shouldn't we? If we double that. 175 times 2 is 350, isn't it? Right, so if we're moving left, that means this bit is going to get dropped off, going to get lost. So it's these that we want to write out. So I'm going to write 0, 1, 0, 1, 1, 2, 3, and then the gap has got to be filled in with a 0. Because I moved it that way, that's where the gap is. That's not 350. What's happened?
As you move it to the left, the 1 has come out to 8-bit line.
Yeah, we've dropped it off. It's gone into a carry. It fell off into the carry.
So I'm not sure, but when I did it, I just assumed that it would be 256 when you moved it.
Now, one thing that you've got to do is you can't like fudge anything. All you do is you say, like, I'm going to shift them. If something falls off, it's gone. So you can't like make it up. Yeah, you might say you'd round it up to 256, wouldn't you? That's as big as, but you can't do 256. What's the biggest number in 8 bits?
255.
Yeah, 255. All the bits set to 1. 255. That would be the biggest. Right, so what we've got, the number we've got is actually too big. If I ask you to write down 350 as an 8-bit number, you would tell me you can't. That would be your answer. You wouldn't try and give me 350. You say, I can't. Not in 8 bits. So we've actually got overflow. And we get overflow when we add as well. When we add 2 binary numbers together. Overflow. The result is too big. But it's not the same thing when we're shifting. We just say, we've lost a bit. So we get a nonsensical number. Right. What I would like you to do